Hello everyone, this is Mohammed, and in this video I'm going to go through experiment number 3. Make sure that you have read the experiment before watching the video because I'm going to go through the most important concepts in here. Mainly I'm going to be talking about the superposition principle. So in the previous experiments we saw how we got introduced to Ohm's law, KVL, and KCL, and then in the second experiment we saw how we can analyze a non-linear circuit with the load line analysis method. In this experiment we will see how we can analyze circuits with more than one source in them. So take for example this circuit. I have a voltage source and a current source. How can I go about analyzing this circuit? For such circuits, we use the principle of superposition, and the principle of superposition simply states that when in a linear circuit containing multiple voltage or current sources, the net voltage or current at any location will be the summation of the voltages or currents that would be caused by each source individually. So if I were to analyze this circuit using the superposition principle, first we start by zeroing out each source individually. So first, let's start by zeroing out the current source, and it's important to note that to zero out a current source, or to kill a current source, we replace it with an open circuit, just like that, and to zero out a voltage source, we replace it with a short circuit. So after I have zeroed out this current source, I can simply find the contribution of the voltage source to the voltage across R1. We can do that with KVL. So apply KVL in here, we get VR1 equals V1. And then we will find the contribution of the current source to the voltage across R1, and to do that if you look at here, the current is going to go from the current source and it's going to come here. Since we have shorted the voltage source in here, then no current is going to pass through this resistor. All the current is going to pass through here because the current will take the path of the least resistance. So since the current through R1 is 0, then according to Ohm's law, V equals IR, I is 0, then V is 0, so VR1 equals 0. Therefore, the superposition principle yields the net voltage across R1 is going to be V1 plus 0, so V1 plus 0, and it is simply V1. It is somewhat a surprising result that we have one whole source that contributes nothing to the voltage, but this is how it works. And that's it for the theory.